Hello everyone. Today we are going to talk about Chapter 10, Venus and Mars. Venus and Mars share a lot of similarity as the Earth. First, they are both terrestrial planets. And Venus is a little bit closer to the Sun, and Mars is a little bit further away from the Sun. And their size is kind of comparable to the size of the Earth. And we'll talk about more detail of these two planets in this chapter. Let's first take a look at Venus. Venus was thought to be a habitable planet as Earth long time ago. If you look at the Venus using the visible light or ultraviolet, you can see Venus actually have a very thick clouds layer. There is no way we can just use optical telescope or the visible light to see the actual surface feature of Venus. And because of its thick atmosphere and the very large coverage of clouds, Venus can reflect a lot of sunlight. So therefore, Venus appears very bright in the night sky. So when you look at night sky, one of the most bright objects will be Venus. Now let's look at some numbers, the property of Venus. The semi-major axis of Venus is 0.72, so for that it's a 1 for Earth. So you can see Venus is closer to the Sun than Earth. And because it's closer, its orbiting period is actually shorter, like 0.6 years. Venus is slightly smaller than Earth in terms of mass and size. And if Earth's mass is 1, Venus is about 0.8. And Earth's diameter is a little bit larger, just a little bit larger than Venus. So therefore, Venus is nearly our twin in size and mass. Now let's take a look at density. Remember, we talked about there's a lot of good information contained in the density value. You can see Venus density is 5,300 kilogram per meter cube, compared to the Earth is 5,500. You can imagine the similarity of the density also indicates the similarity of the compensation. So that means Venus will most likely have our sizable metal core at the center, because all the outside or near the surface of Venus is actually made from rocky material, which will be similar as Earth because the density is very similar compared to the density of the Earth. Surface gravity is a little bit smaller because it has smaller mass as well as escape velocity. When it compared to the Earth. One property is very different from the Earth is a rotational period. Rotational periods, remember Earth's rotational periods is 1 day or 24 hours, but for Venus, the rotational period is 243 days. And also another property make Venus very special. This rotating and is retrograde. So that means the rest of the planet, for example, the Earth, the Mars, they all rotate counterclockwise, but Venus rotate in the opposite direction. It's actually clockwise and it's super slow. It's 243 days. So Earth is just 1 day. So you can imagine that is something make Venus very special, like standing out. And the surface area, because it's smaller than Earth, surface area is a little bit smaller. And in terms of air pressure on the surface, near the surface of Venus, it's actually pretty large. Remember, if you want to compare this number to Earth, for Earth, the atmospheric pressure near the surface is about 1 bar. So Venus is 19 bars, so roughly like near 100 times compared to the Earth. So Venus actually has very thick atmosphere. And another make it standing out is the surface temperature. Venus is actually the hottest planet in the solar system in terms of surface temperature. Surface temperature of Venus is 713 Kelvin. If you want to translate to the Fahrenheit, it's about 900 Fahrenheit, basically across the globe. So it's really, really, really hot. And we also will talk about why Venus actually is such a hot planet. And if you look at the Venus, the interior, the density, you can see Venus actually have a sizable metal core and similar as Earth. But if you look at the rotation period is very slow. So therefore, in terms of Venus, there's no magnetic field, probably because the rotation is so slow. Remember, for a planet to have magnetic field, you have to satisfy two requirements. One is there's a liquid metal core, and the other is it's a reasonable rotation of the planet. So if it's rotated too slow, maybe that the magnetic field is just so small to be detected. Next, let's get a closer look at geology of Venus. Because Venus actually have very thick clouds, the visible light cannot penetrate the cloud. So therefore, Venus' surface has been mapped by radio telescope or radar signals. And that is one, the space, like the orbit of spacecraft orbit around Venus and take a picture and a video. If we look at globally, Venus is actually have a few fresh craters, so which indicate it has a relatively young surface. Remember, we talked about the cratering period happens, the heaviest bombardment period happening about like 4 billion years ago. If you have less number of craters on the surface, that indicate surface is relatively young. And if you take closer look at the Venus surface, the surface feature is actually dominated by volcanism. You can imagine the hot temperature of Venus is actually make the mantle even hotter. So it's actually in a molten state. It's easier for the material, for the lava or magma to wells up. 75% lowland is a lava plain. There's numerous of volcanic features. For example, if you look at this picture, that is what we call the pancake volcanoes. So that is you have a crack happening on the surface. So the lava just wells up and kind of erupt, but in a more gentle way than most of the eruption of the volcano on the surface of the earth. So this follow or form this pancake shape. And unlike the Earth, the volcano has apparently have a randomly location. Instead, if you remember on the Earth, most volcanoes are like to lay near the boundary of the plates, the crust plates. So that may indicate Venus is actually like the recent plate tectonics. So the crust seems not to move. So the lava just piles up and in a random location. And you can see those volcanoes is not have the shape of a lot of volcanoes on the earth. They're not really tall. There's just like a lava well up from the opening or crack on the crust of the surface. However, there are some surface feature on the Venus indicate some past plate tectonics. For example, from this picture, we're able to see the ridges and the cracks, and there are some location, especially near the equator of Venus, we see the high continental regions that all indicates the past tectonic force that form those features. There's a very interesting feature on Venus. Here you can see we actually call is Miss Piggy corona. So the corona structure is, you can see this is like oval or round shape. And it is believed that this structure, the corona structure, are formed when plumes of rising hot material in the mantle push the crust upwards into a dome shape, and which then collapse in the center as molten magma cools and leak out from the side. So it leaves a crown-like structure, so we call it corona. You can see in this Miss Piggy corona, we actually have Piggy's ears, eyes, and nose. And those ears, eyes, and nose, we believe are pancake volcanoes that actually sitting on this corona shape. Other than those images mapped by radar from the orbit, we actually sent a couple landers to land on Venus to actually take a picture of the surface. In 1917, Venera 7, which is a lander, became a first probe to land and broadcast data from the surface of Venus. However, you can imagine Venus' surface is so hot, so it's not very friendly for those electronics. So the first lander, Venera 7, operated for about 23 minutes before it's actually malfunctioned due to the high surface temperature. Follow that, Venera 9 and 10, they last actually about an hour before overheating after they land on the surface. So you can see the bottom picture is actually picture took by Venera landers and on the surface. Fortunately, although they become overheat and stop to function in a very short amount of time, but we're still able to get some picture from Venus. You can see from this picture, Venus is actually have a lot of rocks, which is very similar as the surface of the Earth. Venus' surface look like orangish because it's a very thick atmosphere actually scattered or absorbed most of the blue light from the sunlight, so left with yellowish and orangish color light. And all speaking in terms of plate tectonics, like impact cratering, for the Venus, the surface feature is actually dominated by volcanism. Now let's move to the other direction. Let's look at the massive atmosphere of Venus. Unlike the Earth's atmosphere, the atmosphere of Venus is about 96% of carbon dioxide, only 3.5% of nitrogen, and the rest a very small amount of other material. Similar as Earth, Venus also has clouds. However, if you remember, on the Earth, the cloud is made from water vapor. On Venus, the cloud is actually made of sulfuric acid. Sulfuric acid is very, very dangerous. It's very corrosive. So if you ever visit a chemistry lab, the place or the container stores sulfuric acid always have this warning sign. So it can cause severe burn on the skin. So you can imagine when these probes, they go through the Venus atmosphere, goes through the sulfuric acid clouds and finally lands on the surface of the Venus, and it is such a difficult journey for this lander or probe. And of course, and for human being, I don't think anybody can survive the sulfuric acid on the surface or atmosphere of Venus, in addition to the very hot temperature. And if you look at the location of the Venus in the solar system, Venus is actually not the closest planet to the Sun. Instead, Mercury is the closest planet to the Sun. But how Venus actually get the title of the hottest planet in the solar system? This is primarily due to its thick atmosphere. And I hope you still remember the greenhouse effects we talked about when we talk about the Earth. The greenhouse effect is basically when the sunlight coming from the sun and absorbed by the ground. Due to some greenhouse gas and clouds in the atmosphere, not 100% energy received from radiated from the surface will escape into space. Some of them will reabsorbed by the greenhouse gas and therefore keep in the atmosphere close to the surface. Let's take a look at Venus greenhouse effect by looking at this picture. You can see because Venus have very reflective clouds layer, a lot of incoming sunlight are reflected. So therefore, there is really a small amount of energy from the sun can eventually reach the surface. So the surface of Venus actually absorbs the energy from the sunlight. However, the surface radiates the infrared radiation from the surface because 96% of carbon dioxide and the thick atmosphere, like about 100 times thicker than what we have on the Earth, almost all of the infrared radiation emitted from the surface are retained or reabsorbed by the atmosphere. Therefore, there's only a very small amount can escape into space. So you can see, and Venus were able to keep most of its heat or energy from the sun in near the surface in atmosphere or on the surface. So the greenhouse effect is actually a primary reason maintains the high surface temperature of Venus and make it the hottest planet in the solar system. Why Venus actually able to have such thick atmosphere? If we think about the very beginning when the planet was first formed, you can imagine Venus and Earth, they form at a similar location within the solar system. They probably form at the similar because they actually gather similar material in the same region. So Venus probably reached its current status from more Earth-like initial condition and due to a runaway greenhouse effect. What is a runaway greenhouse effect? And turns out because Venus is just a little bit close to the sun, so that means even smaller amount of extra heat you can imagine can lead to increase of evaporation of the water from the surface. Used to be can be an ocean or river. And therefore, the water vapor will be a part of the atmosphere instead as liquid water on the surface. And those water vapors will be have a chemical reaction with the sulfur released from a volcanism, so they form the sulfuric acid. And because as we have more water as a water vapor actually in atmosphere, the surface temperature increases further because there's no ocean on the surface or water on the surface to absorb the heat. As a result, some carbonate rocks can actually release more carbon dioxide, therefore contribute into the additional gas into the atmosphere of Venus. With more carbon dioxide and water vapor, both kind of greenhouse gas, and the addition of this gas will amplify the greenhouse effects in Venus' atmosphere. You can see this is kind of a very bad circle with even higher temperature. You will basically add more carbon dioxide into atmosphere, and which will lead to even higher temperature unless other process intervene with this cycle. Therefore, the temperature continue to rise. So such situation we actually call runaway greenhouse effects. So you can see Venus actually therefore become hotter and hotter, and with more and more carbon dioxide in its atmosphere, and finally it loses all the water, liquid water on the surface, and therefore there is no chance for life to start and exist at that environment. Therefore there's no way for the lives, for example plants, to get rid of carbon dioxide and produce oxygen. Study the condition of the Venus actually can give us some idea of what's going to happen to the Earth if Earth's temperature keep rising. So basically Venus is a consequence. If we do not control the temperature rising or the level of carbon dioxide in Earth's atmosphere, we basically are trying to push Earth into the direction of Venus. You can see so far, you already know that it's a very hot and it's not a comfortable environment. Now let's move to take a look at Mars. And Mars is also one of the nearest planets to the Earth. Compared to Earth, Mars is a little bit further away from the Earth from the Sun. So that is the fourth terrestrial planet from the Sun. And you can see if we use telescope or orbiter to look at Mars, you can see dark markings, and those dark markings sometimes seems it actually have a seasonal change. And early in 20th century is what widely believed that looks like there are canals of Mars may indicate intelligent life there. And you probably heard about a lot of science fiction talk about Martians. They even draw the Martians with big head and a skinny body. And also the change of dark surface was one thought suggests there's a seasonal growth of plants on the surface of Mars. And you can see clearly from this picture, Mars have what we call the polar cap near the poles. So therefore, for a very long time, we actually also keep a very good hope on the Mars we can find some sort of life or even intelligent life as human being on the Earth. Now let's look at some property of Mars. And Mars is further away from the Sun compared to the Earth, so therefore its orbiting period is a little bit longer than Earth. However, Mars is actually smaller than Earth, so the mass is only about 10%. The diameter is about half of the Earth. One thing that is very different from the Earth is the density of Mars. Remember, Earth's density is 5,500 kilogram per meter cube. However, Mars, the density is less than 4,000. So this density also indicates what kind of material Mars is made from. So at least from here, you know Mars may not have a sizable metal core, because the metal core with high density will make the overall density of a planet very high. So Mars, it will basically have majority which is a rocky material. And the surface of gravity, of course, is less than Earth because it's smaller and less massive. So the escape velocity for mass is therefore almost a little bit less than half of what that on the Earth. So you can see because of that, the objects can escape from Mars easier. And later we'll talk about Mars actually have very thin atmosphere. That is one of the reasons, because as it gets a little bit hotter, air molecule can escape Mars atmosphere or gravitational pull easily and therefore just drift into the space. The most similarity between Mars and Earth is a rotational period. For Earth, it's about 24 hours, and for Mars, it's 24.6 hours. So that means Mars actually have the similar daily cycle as the Earth, the same length of the day. And in addition to that, if you look at the Mars rotation, the rotation axis is also similar to what we have on the Earth. Is about 25-degree tilted to this horizontal direction, or its orbiting plane around the Sun. I hope you still remember that the rotation, the tilt of Earth's rotational axis actually result the season on the Earth. So therefore, if you talk about Mars, Mars actually have the similar season like Earth due to the similar angle tilt of the rotational axis. So therefore, at least if once we landing on the Mars, we're able to experience the similar season as well as a similar daily cycle. The surface area is smaller due to smaller size. And one thing is very different is the air pressure near the surface of Mars is even less than 1% of that Earth. So therefore, that means the atmosphere of a Mars is very thin. It's about 100 times less than what we have on the surface of Earth. And in terms of surface temperature, if you look at the coldest location near the pole of Mars to the hottest location near the equator, that's a range from 120 Kelvin to 300 Kelvin. If we interpret that into the Fahrenheit, that is from negative 243 Fahrenheit to about 18 Fahrenheit. So you can see the hottest temperature sometimes is comparable to the room temperature of the Earth. And in terms of magnetic field, there is no what they call global magnetic field. You can see Mars actually have a similar rotation speed compared to the Earth. We think there's no global magnetic field is probably due to the small mantle core. Either it's non-liquid or the mantle core is too small, or there's no actually sizable mantle core at the center. You can see that it's reasonable because its density is much lower than what we have on the Earth. Now let's take a closer look at the surface of Mars. And Mars is one of the most explored planets. Most of what we know about Mars is actually derived from the spacecraft program. This is a highly successful program. So we have orbiter spacecraft orbiting around Mars, so we can take a picture of Mars from different perspectives. We also have landers which land on the Mars and rovers which are actually able to travel on the Mars to different locations. And you may heard about some of famous one like Pathfinder. We also have able to study a few Martian rocks, and since some of them are reach the Earth as meteorite. And let's take a look at some of the rover and lander. The first one is rover Curiosity. You can see this is actually have a similar size of our SUV. So you can see it have multiple cameras. It's also bringing on a lot of devices, taking the picture and do the on-site analysis. Another very famous lander which is the Mars Insight, so which is the bottom one. You can see this bottom one is actually it cannot travel around. Instead, it was sent to study the interior of Mars because it can have some probe. It can actually drill on the surface, so therefore it can either detect the seismic wave of the Mars or get some sample a little bit deeper underneath the surface of Mars. Definitely, if you want to know more mission of Mars, you can always go to the NASA website called Mars Exploration. It actually lists all these landers, rovers, orbiters that sent to Mars. So you can see this is the InSight lander we just talked about. Now it's no longer in service. The most recent Mars rover is Mars 2020 Perseverance. If you click on each mission, you're able to read more detail about the mission. It will also lead you to the mission website. There's a lot of information in the mission website. You can see you have a lot of pictures, and it also show you a lot of technical details. For example, if you want to know more about the mission Perseverance rover, we can go to the overview, and we can look at what kind of instrument is actually on board this rover. And if you're interested in the video and the pictures took by the rover, you can go to the multimedia. You can see Perseverance also have a little helicopter on board on it, actually called Ingenuity. And you can see that's all the Martian surface picture took by this mission. And as well as the videos, if you want to look at some videos, you can definitely check out this website. So they actually show you a video of different location and took by this Perseverance rover mission to Mars. Those are very interesting videos. So you can see that just for Perseverance, we already have a lot of picture and a lot of videos. Basically, you can see, and a few days, there's a Perseverance will send us a fresh picture and a video that took from Mars. So other than this mission, the one we are mentioning, Curiosity, is also still on Mars, and you can also know that's a very famous one, Mars Pathfinder. You can click on this mission to know more about it. So you can see Exploring Mars is actually a very successful program. So we have a lot of information, a lot of picture, and a lot of video on the Mars surface. Next, I want to share with you a video of 15 years of Mars exploration. 2015 is actually marked the 15 years of Mars exploration. And this is a very good video to summarize the past missions, although it haven't been able to include the most recent ones, but it's a good summary of all the missions and what they actually did and how they land on the surface of Mars.
Hey, there she goes. That's Data.
Preliminary analysis of this data. Can you describe what you see on Mars?
Yeah, it's there. back for touchdown.
Led by the extraordinary men and women of NASA in our Jet Propulsion Laboratory. Right now, the wheels of Curiosity have begun to blaze the trail for human footprints on Mars.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity will stand as an American point of pride far into the future.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.
You can see in this video, of course, the very important step in future is with knowledge more about Mars. There's one day we're able to send people to Mars. And you can see the scientists are all very excited once the mission is successfully land on Mars, because anything can go wrong. In this video, it only showed you the successful mission that on Mars. So actually the successful rate is pretty low. So half of the mission is actually unsuccessful. There's anything can go wrong, and usually the spacecraft will need to travel a couple of years before it's actually reach near the orbit of Mars or finally reach the surface of Mars. Now let's go ahead to take a look at Mars as a globe. So those are the data from the orbit that orbit around Mars to look at it globally. You can see clearly we're able to see a lot of craters on Mars, especially near its southern hemisphere. So you can see this side is a southern hemisphere, this is northern hemisphere. And which also southern hemisphere actually have a higher altitude than northern hemisphere. If you look at northern hemisphere, this looks like lower volcanic plain, and it have a fewer craters. And there are also some significant surface like landmarks or features on Mars. You can see clearly, and near the equator or the center of the Mars, you will see there's a big tear on the crust, a canal or like a valley, a big valley on the Mars. We'll talk about a little bit later. And especially we'll see very high elevation. Those looks like big volcanoes on Mars. And we'll see even within the southern hemisphere, we're heavily cratered. It looks like there's a low basin near in the southern hemisphere. So you can see, I want to ask you to think about in terms of number of craters, which hemisphere you think on the Mars is older? As we talk about, the one with more crater is actually indicated older surface. So therefore, the southern hemisphere of Mars is actually older than the northern hemisphere of Mars. Now let's take a close look at these features, big features and the surface features on the Mars. As we already talked about, even from the global perspective, we can see there's big volcanoes on the surface of Mars. Actually, Mars have the largest volcano in the solar system, which is Olympus Mons. You can see this volcano is more than 20 kilometer height. The highest mountain on the surface of Earth is just 8 kilometers, and 500 kilometers in diameter. So this is a huge volcano, which is Olympus Mons. And the tear or the valley, a canal, and which is a very significant feature on Mars and near the equator, and make past observers think about this canal built by intelligent life on the Mars is like just generated by the kind of some plate tectonics, and this is what we call valles marineris. These canyon are the tectonic feature, and they then widened by erosion. Unfortunately, it's not a canal built by intelligent life, but it's really, really significant, and which is about 3,000 kilometers long and about 8 kilometers deep. So therefore, you can fit Mount Everest within the canal. And of course, a lot of surface features are obtained by the picture from those rover and the lander. You probably already see the Vulcan's mission and the Pathfinder mission from previous video, and you can definitely find more about them in the NASA website, Mars Exploration. You can see, and of course, I hope everybody understands the purpose we're so interested in Mars, because in future we want to land on the Mars, maybe establish or like a settlement or look like space station or station on the Mars. And we're very, very interested in looking for the life on another planet, as well as what we believe is essential for life is water. So therefore, when they choose this landing site, of course, they want to choose a location is easier for the those lander and rovers, not on a big slope. And the other most important reason for this lander and rover is they want to looking for the evidence or looking for life. So therefore, it being selected to search for the evidence of life or past water, because we believe water is very essential for life. If the life on Mars is similar at what we have on the Earth, the life on the Earth was originally inside the ocean. So if we can find water, and most likely, hopefully, we were able to detect some format of life in the water. You can see Viking 2 is landed near the North Pole of Mars, and Viking 1 and Pathfinder is landed near the equator. And the temperature we know about Mars is actually coming from these lander and rovers. They actually bring the thermometer with them so they can measure temperature on Mars at different locations. And if you look at the surface of Mars, is also, you can see there's a lot of rocks. You can even see some of the debris of the mission we sent to Mars. But looks like the dry and red. Sometimes we call Mars is a red planet because the overall color is red. The reason the soil or the land looks red because we believe there's actually a lot of iron compounds like the rust actually on the soil or on the rock, so actually makes the color red. Actually on the surface of Mars, there are a very strong wind. Those wind is actually responsible for the seasonal change of like dark markers we talked about previously on Mars. So this is not a seasonally change of plant. Instead, the winds bring with the sand, and which generate what we call dusty devil, actually plays a very important role to redistribute the surface material. Because we have so many missions on the Mars, we actually have pictures of Mars surface at a lot of different locations. Because we have so many successful missions to Mars, so therefore we actually have a lot of pictures of Mars. I want to share you with a video. The video is long. We'll share with you a few minutes. So we can at least take a look at how the Mars surface looks like.
The team at NASA has given Mars informal place names, which you will see on the screen in the bottom left corner. The footage was mainly captured by the 3 most successful rovers, Spirit, Opportunity, and Curiosity.
You can see due to the successful missions, we actually have a lot of videos at different locations on Mars. There is some part of Mars looks like a desert on the Earth, but you can see there is some part like a dry lake bed. But from this video and the picture, none of them show there's actually liquid water on the surface of Mars for today. And the next video I want to share with you is this dust devil on Mars, and that is due to the high wind. It's actually bring the dust or the topsoil from the surface and move it around on the surface of Mars. That is also what we actually see as the seasonal change of dark marker on Mars. And you can see those looks like small tornadoes are the dark dust devils. As I mentioned, one of the purpose of the mission is actually looking for water and life on Mars. And clearly, actually, Mars has a significant amount of water ice. So let's first look at the Martian atmosphere. As compared to the Earth's Martian atmosphere has a pressure of less than 1%, so it's like 100 times thinner than that of the Earth. And unfortunately, 95% of the Martian atmosphere is made from carbon dioxide to indicate the lacking of the plant's life, which convert carbon dioxide into oxygen. And as well, on Mars, there is a lot of clouds. And these clouds actually have like dust clouds due to the wind bring some of the dust from the ground into the atmosphere. And they also have a water ice cloud and the carbon dioxide dry ice cloud. Slightly different because Mars, in overall speaking, is colder. So carbon dioxide, the gas can just directly freeze, become dry ice on the surface of Mars. And from all the images we take, you cannot really find liquid water on the surface. We're able to find ice. For example, one of the pictures here, the lander and the scoop a little bit deeper into the surface, you can see definitely there is the ice. The white is the ice. If you wait for a little bit time, you can see some of the ice is actually evaporate directly, or we call the sublimated, which is when the object of material from its solid state directly becomes its gas state. So, which is definitely good news because underneath it may indicate there's a significant amount of water ice underneath the surface. And I want to take a little bit time to explain why liquid water on the surface is not really possible for Mars, or is hard to find on Mars. Think about the liquid water on the Earth. As long as we have a temperature between 0 Celsius or 100 Celsius, which is 273 Kelvin to 373 Kelvin, water will be shown as a liquid form. And you can see on the Earth, most of the place actually, on average, is within this temperature range. As we already talked about at the beginning of the semester, and the factor can affect the change of status, the states of the matter. Temperature is 1. When it gets too hot, liquid can become gas. Another very important thing that play a very important role is actually the pressure. So because Earth's pressure is about 1 bar, so therefore, even at 100 degree, below 100 degree, water is very stable. If we move on Mars, because Mars atmospheric pressure is only like 1%, due to the lower pressure, the molecule in the liquid can easily break down the constraint and become water vapor. So therefore, pure water, if it's a pure water on Mars, will only exist between 0 Celsius and 10 Celsius degrees. So which is less than 300 Kelvin. So therefore, there's a very small range of temperature that water will be stable on the surface of Mars. If any location have a temperature lower than 0 or higher than 10 degrees within a day, the water will either become water ice or evaporate as a water vapor. So pure water on Mars surface is very unstable. However, in 2015, NASA actually published a great news that it actually found kind of the evidence of salty water flow on today's Mars. And although it's not right like ocean or river as we see on the Earth, but occasionally there's some water flow, and therefore at the same time and left with some features. And why the salt water? You may heard about it in winter. If the city want to defrost the frozen road, they will put a lot of salt. Once water have salt dissolve inside, so the salt will able to make water as a liquid form as low as -17 Celsius, and also make it stable on Mars even with such low air pressure up to 24 degrees Celsius. So you can see most likely if we able to find a small amount of water on Mars, this most likely will be salt water instead of pure water, because which one is more stable. Another place actually have a large amount of water ice is actually from the polar cap. Both North Pole and the South Pole on Mars actually have the polar cap. Unfortunately, due to extremely low temperature, water is actually permanent froze. So sometimes we call the water ice residue cap. So water ice residue cap, they never melt. What actually changes seasonally is a dry ice. So that is solid carbon dioxide. So carbon dioxide can supplement it when the temperature is a little bit higher and become dry ice when the temperature is low. So you can see, even if with not significant amount of liquid water, but Mars do have a lot of ice. Yeah, if we establish a settlement on Mars, we can definitely make good use of this ice and convert it into liquid water. And although nowadays Mars looks like a dry planet, but when we look at a lot of features on Mars, it actually shows a strong evidence there used to be a lot of water on Mars in the past. For example, if you look at the top image here, you can see this is a lot of water erosion features. It's a runoff channel, like a lot of small streams of water like flow on the surface, and outflow channel. This one looks like our creek, dry creek bed. Unfortunately, nowadays it's dry, but it's clearly show this is carved by the water erosion. And other evidence indicate there's a large amount of water in past. When we look at the Asian lake bed, we're able to see a lot of a cracked mudstone, which usually only found at the bottom of the lake. And also there's a lot of what we call sedimentary rocks has formed, which we believe also usually due to the process involving water. And you can see again this image, we believe that is actually the flow of water actually carve the shape of the rock into its current appearance. And more exciting is that we're able to see some gullies, then that is the water actually flow from a higher location to lower location and erode on the slope. It actually shows the present flowing of salty water. If you look at this image, that there's some gullies actually have dark color. The dark color gully just means it's recently formed. If we look at the same location at a different time and wait for maybe a few months, a few years to look at the same location, the picture taken by the spacecraft were able to see the newly formed gully. So that means those salty water actually occasionally flow on the surface to generate off and to carve the gully. However, due to the water is not very stable, they can be evaporated quickly or frozen quickly as ice and underneath the surface. But it's a very exciting news is that we're able to see actually salty water present on Mars today. So at least for now, comparing Mars and Venus, definitely Mars is better than Venus in terms if we want to settle a settlement. And although it's definitely not as habitable as Earth, but it's definitely better than Venus. There's also a lot of other pictures like Asian River Delta and a lot of picture and indicate the past water flow on Mars. You can definitely find more of this picture from a NASA website. And finally, I want to talk about the evolution of the three planets, the Earth, Venus, and Mars. Remember, when they form, they gather the same amount of material from solar nebula in pretty much the similar region. So you can imagine they probably get the similar amount of different kinds of material. So at the beginning, they actually looks very similar a long time ago when first they formed. However, nowadays, if you look at Earth, it's a very habitable place. Instead, Venus is too hot and the atmosphere is too thick. However, Mars is too cold, no liquid water, and atmosphere is so thin, so make them like uninhabitable. And we believe they must be diverged in their evolution from what we may have been similarly at the beginning. Let's review a little bit about the Earth. Remember, the Earth still begin with large amount of carbon dioxide. However, due to the temperature, the Earth actually have liquid water. Those carbon dioxide can dissolve into the ocean and therefore later on bound into rock formation, the carbonate rocks. And later on with the plant life, this further remove carbon dioxide from atmosphere and replaced with oxygen. So therefore it's very essential for animal to finally appear on the Earth and made Earth a very habitable environment. However, if you look at Venus, the only difference is from the very beginning between Venus and Earth is that Venus is a little bit closer to the Sun. Because it's a little bit closer to the Sun, it's actually start with a little bit hotter temperature. However, this higher temperature have play a very, very different role and make the planet Venus evolve very differently from the Earth. Because Venus is hotter and the water actually evaporates as water vapor and the carbon dioxide cook out from the rocks and therefore put more material or gas into atmosphere, therefore make atmosphere thicker and thicker. And the consequence of that, the thicker atmosphere will basically increase the greenhouse effects, make the surface even hotter, and therefore evaporate more water and cook out more carbon dioxide. So this is a runaway greenhouse effect. You can imagine ultimately, because it's a hot temperature, no water ice or like liquid water can survive on the surface of Venus and therefore make it very uninhabitable. So you can imagine for the temperature on Venus, even in that electronics cannot survive. So this is definitely not a habitable place. You can see this is just because Venus is a little bit hotter to start with, which led to what it become today. Definitely Venus can be a good lesson we can learn is that if we keep dumping more greenhouse gas into Earth's atmosphere, we actually push the Earth into the direction of Venus. On the other hand, Mars is actually further away from the Sun, so it will start with a colder temperature. However, this colder temperature actually make water ice froze. Therefore, the surface become more reflective and therefore, because it's losing more atmosphere, now the water vapor no longer able to in the atmosphere due to the cold temperature, and therefore there is a much less amount of greenhouse effects. As the temperature keep dropping, carbon dioxide actually froze from dry ice. therefore finally result a very thin atmosphere. And therefore, there's not enough greenhouse effect actually on Mars to keep it warm. So we call it a runaway refrigerator effect. Due to the cold temperature and lack of liquid water for today's Mars, which it actually and thin as well thin atmosphere, which actually make it uninhabitable place. And on Mars, we're able to find a lot of evidence of past water flow, but unfortunately, we haven't able to find any life on Mars yet. So you can see that you should feel very lucky we actually live on the surface of Earth. The Earth is really a lucky one. It's not too far away or too close to the sun. It's right at the perfect location in the solar system, so it can receive the right amount of energy from the sun and have a right amount level of atmosphere to have a correct right amount of a level of greenhouse effects, so therefore make it a habitable planet for the life. You can compare the atmosphere of Earth, Venus, and Mars in terms of the density or thickness. It's just like you have a blanket. The Venus have the blanket like 100 times thicker than what we have on the Earth, so it's making it very hot. On the other hand, Mars have a blanket so thin that cannot keep it warm. However, Earth have the blanket at the right thickness, keep Earth warm at a comfortable temperature. That is all I want to talk about for chapter 10. In chapter 10, we first talk about the Venus, which is a little bit closer to the sun compared to the Earth. And Venus is actually the hottest planet in the solar system. We have retrograde motion and a very slow rotation. And Venus is not habitable. The surface is dominated by the volcanism, and the atmosphere is very dense, and the clouds is actually made from sulfuric acid. Most of the air is made from carbon dioxide. And then we talk about the Mars. Mars is smaller than Earth, further away from the sun compared to the Earth. And Mars have a surface actually have some crater, the huge volcanoes, Olympus Mons, and Valles Marineris, which is a big valley or canyon on the surface of Mars. Other than that, there's a lot of surface feature on Mars indicate there was water flow on Mars. For example, the dry lake beds, the run-off channels, and of course, we also found the evidence, the newly formed gully, and actually show that there is still some salty water occasionally flow on the current Mars. But Mars do have a big reservoir of water ice, either underground or near the North and South Pole. And finally, we talked about the initial difference of the temperature actually may lead to the very different evolution paths of Earth, Mars, and Venus.